Okay, in this video I'm going to look at some applications of derivatives that are certainly relevant for business students like the ones who take Math 102. I have here a cost function and a demand function which indicates price. Both are functions of x, which is the number of units that are produced in the case of a cost function, or units sold in the case of demand function. And various problems in this section, section 2.4, deal with functions that come from the cost and demand functions: average cost, marginal average cost, revenue, profit, and marginal profit. So what I'm going to do is show you how you can obtain all of these functions from these two that I've made up here, the cost and demand functions. In one or two problems, you may have to come up with the cost function based on a verbal description instead of a formula like I have here. So I can break down this cost function as, first we have this constant term, the 2100 in this case. That refers to fixed, or possibly referred to as startup costs. So for instance, maybe the cost of buying the equipment to produce your goods might be the fixed cost. Then the remainder of your cost function that actually depends on the number of units produced, that would be your variable cost. So what you could say is that I could break this down into, if I factor an x out of the rest of this cost function, then I have 23 plus 0.2x, all of it times x. So I could say that the total cost of producing x units includes the $2,100 of fixed costs, and then for each unit produced, that occurs an additional cost of 23 plus 0.2 times x per unit. So you have to multiply all of that by x. So that is how a cost function is expressed in terms of fixed costs and then cost per unit on top of those fixed costs. Okay. Now, given that our cost function is denoted by c of x and a demand function by d of x, here's how you can obtain all of these functions from them. First, the average cost, which I'm going to denote by c bar of x. The bar is often used to denote average, and this is a notation that you'll see in Hawks. That is just defined to be the cost divided by x. So in this case, it would be 2100 plus 23x plus 0.2 x squared, all divided by x. And then if you want, you could simplify that. So that would be 2100 over x plus 23x over x, which is just 23. And then 0.2x squared over x, which would be 0.2 times x. Next, we have the marginal cost, c prime of x. So that would be the derivative of the cost function. So I could take the derivative of this just using the power rule. I could take a derivative of each of these three terms individually using a power rule and then add up the results. So first we have 2100, but that is a constant. The derivative of that is 0, so that will not be included in our derivative. And then we have 23 times x. The derivative of x is 1, so a derivative of 23 times x is just 23 times 1. So we have 23 for the first term. And then moving on to the next term, I have 0.2 times the derivative of x squared, which is, as we've seen before, 2x. So all told, we get 23 plus 0.4x. Notice that the marginal cost is somewhat similar to the average cost. Notice they both have a 23. They have different multiples of x, but the marginal cost gives a more accurate indication of how much, if you're already producing x units and you're going to produce one more unit on top of that, what that cost is going to be. Whereas the average cost takes into account all units that have been produced, all x of them. Marginal cost is about if you're producing one more. So even over similarities, they have very different meanings. The marginal average cost is the derivative of C bar. So you take your average cost function from before, and now you take its derivative. So that would be the derivative of this function right here, which I can rewrite, and I'm going to rewrite it before I take its derivative, as 2100 x to the minus 1. And then the rest I'll leave as is. Because now that it's written in this form, it's easier to take a derivative using the power rule. So what I'll get is 2100 times the derivative of x to the minus 1. Using the power rule, you pull the exponent down. So that's minus 1 times x to the minus 1 power. So that's the minus 2 power. That finishes that term. Then on to the next term, 23 is just a constant. The derivative of that is 0, so we ignore that. And finally, to the last term, we have 0.2 times the derivative of x, which is 1, so we get 0.2. And now I can rewrite that as 0.2 minus 2100 over x squared. So what this says is, as the number of units produced x increases, this term is going to get smaller and smaller because your denominator is getting larger and larger. So as the number of units increases, your marginal average cost converges to 0.2. Now, the demand function is going to come into play. So the demand is used to set the price of x units. Okay, the recording got interrupted there. So the revenue is the number of units sold times, well, I'll denote it by R of x for revenue. So the revenue is equal to the number of units sold, which is x, times the demand for each unit, which is d of x. So all I have to do is multiply my demand function, which indicates my price, by x. So I'm going to get 600x minus 10x squared. So now that I have my revenue function and I know my cost function, I can easily compute my profit. So profit, P of x, will be equal to my revenue minus my cost. So that's going to give me 600x minus 10x squared minus my cost. So I'm going to put that in parentheses, 2100 plus 23x plus 0.2x squared. So once I combine like terms, I'm going to have minus 2100 for my constant term. For my linear term, I have 600 minus 23x, so that's 577x. And then I have minus 10x squared, and then minus, because it distributes, 0.2x squared. So I have minus 10.2 x squared. So this function describes my profit if for producing and then selling x units. Finally, the marginal profit, just as marginal cost is a derivative of cost. Marginal profit is a derivative of profit. So I just have to take the derivative of this function here. Well, minus 2100, that is a constant, so its derivative is 0. Then I move to the next term, I get 577 times the derivative of x, which is just 1. So I get 577. And then I have minus 10.2 x squared, so that would be minus 10.2 times the derivative of x squared, which is 2 times x to the first, so 2x. So then I can simplify. I get 577 minus 10.2 times 2, so that's 20.4x. So I'm going to box my final answers here. So, given cost and demand, to recap, we have average cost, which is just cost divided by the number of units. A marginal cost is a derivative of cost. Marginal average cost is a derivative of average cost. Revenue is your demand function times x. Profit is revenue minus cost. And finally, marginal profit is just the derivative of profit, the same way that marginal cost is the derivative of cost. So here's how you can obtain all the functions that you need to work with problems in this section.